Let's compute the derivative of the function kx to the n. In the notes, n is equal to 3, but we can show this for an arbitrary value of the power n. We've reproduced here again the definition of the derivative. When we compute the derivative of this function, we have to compute the following expression: k times x plus h raised to the power n minus k x to the power n divided by h. And let us recall on the side here that x plus h to the power n can be written as x to the n plus n times h, x to the n minus 1, plus a whole lot of other terms, which it turns out are not going to matter. These are the only two terms that we'll be keeping, as you'll see shortly. We can take the k out from both of these terms, and in fact, since it does not involve the limit at all, we can put it out in front of the limit, and then inside we're going to have terms of this form plus a lot of other terms that have higher powers of h minus x to the n from here, and all that is divided by h. Now let's observe that we can do some cancellation. So for a start, we can cancel out the factors of x to the n here and here. And next, all of the terms in this expansion have h or higher powers in them. And so we can rewrite this as k times limit as h goes to 0 of the following quantities. We're going to cancel this h with this h, which will leave us n times x to the n minus 1. There will be other terms in here, but they will be either proportional to h or to h squared, etc. So as soon as we evaluate the limit, these terms will basically go to 0. The only term which will be kept is the term that has no h's in it. And so all in all, we're going to get k times n x to the n minus 1. And that's where the power rule comes from.